Good afternoon, everyone, and welcome to today's webinar. Our topic today is preparing to maximize indoor air quality post-COVID-19. Before we get started, I'd like to take a moment to go over a few housekeeping items. My name is Allison, and I will be the webinar organizer for today. We want to make sure today's presentation is extremely valuable for you, so we ask that you submit all questions by clicking on the question button in the control panel and typing your question. Right now, please join me in welcoming Nicole Sticka, Vice President of Energy Services at GCP.
Thanks, Allison. Good afternoon, and thank you all for joining us today. As Allison said, my name is Nicole Sticka, and I'm Vice President of Energy Services with the Greater Cleveland Partnership. Yesterday, Governor Mike DeWine offered guidance for his Responsible Restart Ohio to reopen Ohio's economy in a phased-in approach. As we know, some unknowns remain, and the GCP is dedicated to working with government officials and experts to aid our members, businesses, and the broader community. And we're also committed to providing the best information possible about the economic impact of COVID-19. As such, I'm pleased to be moderating today's webinar on an important topic that is or will be weighing in on people's minds as we resume entry to buildings. We spend more than 90% of our time indoors, and the impact of building design and operations on human health is well documented. Poor indoor air quality costs the U.S. economy a whopping $168 billion per year due to direct medical care and absenteeism. However, efficient and well-designed HVAC strategies can promote health and well-being within an existing space through better indoor air quality. The challenge lies, though, with existing buildings where occupants must live with the existing systems, which may be old and contribute to poor indoor air quality. Employers today are going to be dealing with the reality of radically different expectations and worries that their employees have never had before this COVID-19 crisis. For example, workers will now want more information about the cleaning and mechanical or HVAC measures before returning to the office. There's going to be a lot more interest in the short term on understanding how cleaning occurs, the specific sanitation methods being used, and any extra measures that could be put in place to protect the health and well-being of any occupant in the building. Any establishment now needs to address the risk of airborne transmission through small particles, which may stay airborne for hours and could be transported long distances. Transmission of some viruses in buildings can be limited by changing air temperatures and humidity levels. Today, I'm joined by the Air Force One team, one of GCP members who is also part of our contractors network. We will hear from Greg Guy, Brian Taylor, and Austin Nutter. Please refer to their bios on the event registration page or on the right side of the screen now. We'll first start with Greg, President and CEO of Air Force One. Thank you, Greg, for joining us today. I'll turn it over to you.
Thanks, Nicole. It's great to be with everybody. I hope everyone is safe, healthy, and doing as well as can be expected during this difficult time. I have just a couple quick thoughts for you, and then I'm going to pass it along to Austin. So as I think about COVID-19, you know, as an American, as an Ohioan, it occurs to me that Ohio and America really care the most. I can't think of another community, another country in the history of the world that has been more charitable than the United States of America. And I don't think that there's another state in our country that carries that mantle of leadership, carries that torch of caring and supporting its community of people more than Ohio. And the fact that all of you have dialed in today and are looking at this and are curious about how to make your buildings healthier is just a further example of how much you care about your people, about your customers. And that's really inspiring to me. And so to the effect that our team can help a little bit, you know, that's a privilege for us. And so that's the first thing I wanted to say. The second thing is that, you know, adversity is inevitable. Resiliency, however, is a choice. And again, I think America's response to COVID-19 just further demonstrates our resiliency as a nation. And I think Ohio leads the way in our country in that resiliency. And so that gives me a lot of inspiration as I think about my own organization and everything that we've been faced with and are trying to do for our people, that resiliency that I'm seeing in others is inspirational to me and gives me the confidence to move forward. So thank you for that. So I hope today you find a nugget or two, and I wish you all the best as fellow Ohioans. We're in this together, and we'll get through it together. So with that, let me pass it on to Austin. Thank you.
Thank you, Greg, and I again thank everybody for joining us this afternoon. Thank you, Greater Cleveland Partnership, for hosting this webinar for us. Just a quick background before we jump in. A few weeks ago, GCP reached out to us and asked, how our business was doing, how we were affected, what steps we were recommending to our customers take, and more importantly, just wanting to see if we had any recommendations. And it was interesting because at the time we were working on some pieces internally, because there's a lot of misconceptions and misinformation out there regarding the spread of COVID-19. So that being said, just brief little bit of housekeeping. We're going to keep this short and sweet. The presentation portion of this webinar will be about 30 minutes, 15 minutes afterwards for our Q&A. I please ask that you send in any questions. I will pause briefly in between slides so that we can keep this interactive and keep the questions in line with the proper context. So without any further ado, let's jump in. So topics we'll be covering in today's webinar are ventilation, system filters, routine system cleanings, water treatment, maintaining air quality, and UVC photohydroionization, or PHI. Ventilation is essential to keeping the people in your building safe and healthy, and adding fresh air to the HVAC system accomplishes two primary indoor air quality goals. First is it controls building pressure, but more importantly, it increases indoor air quality by diluting polluted or stale indoor air. We recommend that you ensure your outdoor air intake systems and dampers are operating properly.
And Austin, I'd like to add to that. One of the first items to be disabled on air handling equipment, specifically package equipment, smaller equipment, are the outdoor air dampers. They do increase energy a little bit, but at the same time, it's necessary to properly change the air in the space. So as you're moving back from a work at home to a work at the office, it's very important you make sure all those pieces are functioning as they should.
Thanks, Brian. System filters. System filters keep systems operating efficiently and prevent contaminants from being reintroduced. This was something that's been a point of contention and debate, but simply put, switching to high efficiency filters is very dangerous. Mechanical equipment is designed for specific filters and the pressure drop associated with each class. Higher rated filters will reduce airflow and can cause significant damage. ASHRAE recommends changing HVAC system filters even if they do not appear dirty.
All right, the most important thing is what Austin said earlier, and that is pressure drop. So some equipment may have the ability to go up a couple ratings. At the end of the day, those couple of ratings are not going to make a difference when it comes to COVID. Simply stated, the size would require major HEPA filters, and most, I would say 99% of equipment for anybody that's on this call, unless it's a lab, doesn't have the capability of handling HEPA filters and still delivering the volume of air needed for the space.
Thank you, Brian. Routine system cleanings increase equipment efficiency and aid in reducing premature failure of equipment. Cleaning air ducts and coils minimizes dust, allergens, which reduces the spread of viruses and bacterials. As you can see below, we have some additional recommended cleanings. There is a secondary benefit to this. It'll extend the operating life and reduces the likelihood of any catastrophic failures to your mechanical or HVAC system.
Yep, and just an added piece to that, as equipment runs and your ductwork and your coils and your fan become coated with, first it looks like a light dust, and then it looks like fur, and at the end of the day, it almost looks like a blanket. That takes away airflow, that takes away heat transfer, and it keeps your equipment from running. Bottom line is you're spending more money for less heating or cooling, and at the same time, aiding in the failure of your equipment.
Thanks. Let me take a brief pause. Has any questions come in yet?
Yes, Austin, the question came in of, does Air Force One check this during regular maintenance?
Oh, go ahead. I'll go, Austin. The short answer is yes. On a typical PM, these are all of the items that, whether it's Air Force One or who your specific service provider, should be checking. So evaporator coils specifically, because they're in the airstream of the air that's delivered to the space. Cooling towers, that's a little bit separate, but there are other pathogenic problems that can, Legionnaires is one of them. But ductwork, fan, coils, filters should be part of any routine PM.
Thank you. So Brian just recently touched on this in the last slide, but for water treatment, when water stagnates, it allows waterborne pathogens to grow. Properly treating your water distribution system protects you from Legionella or Legionnaire's disease and prevents other waterborne pathogens. We recommend that you establish, manage, and execute a customized plan as a key defense against contamination issues. This is especially important with steam humidity generators and direct water distribution into airflow.
Right, and something that I'd like to add to that, from the tower side, like an open tower where you have water running across a fill, air pulling up through it, removing the heat. If you do have waterborne pathogens in that, and you have mist coming off of that, and they're being brought into a makeup air system or one of your air handlers, it can distribute those pathogens throughout your entire building, even though the source is outside. So it's very, very important to make sure that that part of your system is working the way it's supposed to and treated properly.
And then I'll take this opportunity. Has any additional questions come in that we can field?
Not at this time.
All right. Thank you, Nicole. So maintaining air quality. Maintaining air quality improves the health, productivity, and well-being of your occupants. Air purification products reduce pollutant levels. Adding UVC or PHI is the only way to properly disinfect air streams. Indoor air quality plays a significant role in reducing the effects of harmful pathogens, and although there are various ways to improve IAQ, research suggests that UVC light in conjunction with PHI will stop the spread of bacteria, germs, fungi, and viruses such as COVID-19, and we are going to address this in later slides. Another important point is your economizers proportion the relief return in outdoor air to ensure dampers allow sufficient airflow and maintain healthy oxygen and CO2 levels.
Yeah, but that just kind of outlines what we talked about earlier.
Correct. And then one other thing that's not on this list, but I do think it's an important thing, is the impact of relative humidity on maintaining air quality. So Brian, could you just kind of elaborate a little bit on that point?
Sure. And I'm not sure if it's later in the slide, but we got a lot of questions when this first started, when the shutdown first started for the state of Ohio. And the question was, we want to shut off our equipment for the fact that there's nobody occupying the building. So if there's nobody there, they don't want to use energy to heat and cool it, which is smart, because there's no sense in using more energy than you need. The part that you really have to focus on is, even though you're shutting it down, you need to set back and set up temperatures that don't allow the building to slide below dew point. Because what can happen is when you start back up and you're bringing in air that's warmer and you're cooler inside, which is really this time of year, we have that, there's a lot of times where that could happen. You can build up moisture around window seals, edges of doorways and hallways and so forth, which makes a very, very, very bacteria, fungus, mold ripe building. So our suggestion has been, if you do set it back, add a 1 hour or 2 hour schedule to your system to allow it to A, purge, and B, make sure that you're replacing that air even if nobody's in there. That way your building remains healthy while you're gone.
Thank you, Brian. And I will ask if any other questions have come in.
Not at this time.
I appreciate it. Moving on. So UVC and photohydroionization, or PHI. This reduces viruses, bacteria, odors, air pollutants, and VOCs. So you're probably sitting back asking yourself, well, how does that work? Well, it creates a bunch of advanced oxidation processes, and I will save you all those terms, but these all can be lumped into friendly oxidizers, meaning these oxidizers revert back to oxygen after the oxidation of the pollutant, and the pollutant has been neutralized. Germicidal UV light rays have been used for decades in the medical industry to destroy germs, viruses, and bacteria. However, UV light is only effective in reducing airborne microorganisms that pass through the light rays themselves. On the other hand, photohydroionization, or PHI systems, can reduce microorganisms by 99.99% in the air and all hard surfaces.
Yeah, and to expand on that a little bit, UV light has also been used commercially in larger systems, specifically on the return side. That way it treats the air going into the coils to really control mold and bacteria growth on the evaporator coil, which, whether it's chilled water or DX, is typically a wet coil. On off cycles, it stays wet, it gets warm, and you have a high probability of growing mold and bacteria, which then you can smell when you start it back up, and it just creates an unhealthy situation. Excuse me. The PHI part is UV light and the photohydroionization, which takes moisture that's in the air, turns it into the friendly oxidizers. Not only does it get treated at the UV source as the air flows by it in the equipment, but it also pushes those oxidizers into the space, which allows it to react with things in the space, whether it's hard surfaces, whether it's in the air. And it basically creates an outdoor summer day indoors when it comes to minimizing bacteria, and we'll just call it pathogens.
Thank you, Brian. So this was a study done on PHI by a third party. And this particular test was looking at H1N1 swine flu. The PHI units were installed and turned on. Within 6 hours, the inactivation rate of the H1N1 swine flu was 99%, meaning at 6 hours, the virus had been neutralized, and if the system continues to run, it should stay and remain at those levels.
I think it's important to understand that this is in the air and on surfaces.
Correct. Has any questions popped up, Nicole? Allison?
Sorry about that. Any thoughts on the use of ozone to treat air quality?
Brian, I'll let you take that because we're kind of talking the same language here.
Yeah, a lot of times people use ozone, and these friendly oxidizers are part of the ozone family. And I know that a lot of times people call this ozone generators, which is true. The benefit is it does treat air quality. As these oxidizers react with any of the pathogens we talked about earlier, the byproduct is oxygen. I know there's concerns. We've had some customers have these concerns. Early on, when this technology came out, there was concern of, would it be like the bad ozone that we don't want, that can be a problem for asthmatic people or cause respiratory distress. Most of that has been dispelled. Most of the information and the long-term use is very positive when it comes to photohydroionization.
Thanks, Brian.
A couple other questions have also come in. How effective and how long do the hard surfaces keep clean and disinfected?
That's a tricky one. So by theory, right? You're constantly adding these oxidizers as these germs, viruses, what have you, are reintroduced, right? Somebody sneezes, somebody touches something. There's oxidizers there to immediately react and deactivate. I can't say specifically that it's 100% all the time, but the reduction is extremely significant.
Yeah, and in this next slide, it kind of shows that this is a similar third-party test. They're looking at mold, yeast, and bacteria. Within a 48-hour period of being treated with the PHI technology, the inactivation rate went to 97 plus, and it was essentially neutralized at 48 hours.
Right. Another piece to add to this. This is a very similar process to what Battelle is using to decontaminate and keep masks in service for the healthcare workers. They're of course using a hydrogen peroxide mist, which is of course not what we want in our buildings, but at a much greater level. So it's the same idea, just at a oxidizer level rather than a mist level.
And we'll be touching on that over the next couple slides.
Austin and Brian, question, where specifically in the HVAC process, and perhaps you answered this, is the PHI actually installed?
On the discharge side.
Okay.
Yeah, so traditional UV is almost always installed on the return side prior to it reaching your coil, whether it's DX, chilled water, hot water. I've seen it also on the downstream side. On this one specifically, it's typically installed on the downstream side. The added benefit is the oxidizers that don't get used in the space come back in the return and also help treat the coil side.
Okay. And I'm going to hold one of these last questions because it may come up in a moment. So please continue.
Okay. All right. We'll check back in here in a second. So some additional PHI lab tests. They did a sneeze test, and I love this picture. It illustrates exactly what we've been told. We've been instructed to social distance, stay 6 feet apart from one another to reduce the spread of this virus. This virus is a droplet-based respiratory virus, meaning that most people that contract it from sneezing or coughing. So they specifically looked at this in this test, and essentially oxidizers are already in the air ready to kill microbes at the source. This has been TSA tested, and the oxidizers immediately reduce microbes by up to 99%.
Yeah, within 3 feet, which I think is very important.
Correct. Now, do you want to? You can ask us the question whether it's pertinent or not. We can address it, and if it comes up later,
Sure.
then we brush over it.
Are there examples of what these systems look like? Are they in the ducts or are they installed within the room itself?
They're installed in a duct, depending on the size of your equipment, their size to provide enough ozone to protect the space, and UV light source that it treats the entire light. But the size and the way the equipment looks is very specific to the size of the equipment that we're doing. So picture, if you will, it almost looks like a flange with the UV light and the catalyst, which is a metal that slide into the duct. And up to about, say, 20,000 CFM, it takes about a 6-inch hole in the duct, and I think it's about 24 inches long. So it's not super intrusive, and it could be installed in most duct systems that are, where you're not just dumping out the bottom and returning up the backside.
And I think a point to be added as well, this system can run 24/7, 365, but it doesn't have to. We typically interlock it directly with the fan.
Brian and Austin, knowing that a lot of companies have reduced budgets, what actions that you've mentioned have the biggest impact in in mitigating any of the pathogens that may be coming through the air, and what steps should a building take? I know often we go into a building to do an energy audit and there's a lot of measures that are not currently in place. Can you speak to perhaps the hierarchy of actions that a building, a business could or should be taking post COVID-19 as we prepare to re-enter our buildings?
I would love to. Let's jump in 2 slides. We talk about our recommendations and we can kind of unpack that question at that time. Does that sound good?
Absolutely.
All righty. Any other ones before I move on?
I don't believe so.
Okay. So hydroperoxides are in the outside air. This is a naturally occurring phenomenon. The sun is a large UV light source that reacts with naturally occurring metals in our atmosphere to create hydroperoxide, or hydroperoxides plural. Hydroperoxides help reduce pollution and make outdoor air feel fresh. Indoor air has no hydroperoxides present and pollutants build up. And this is, one of the reasons we want to find ways to get that fresh air from outside indoors. And I think Brian had something to add to this slide.
Yeah, we've had this discussion before, and at the end of the day, we've had customers ask, well, why don't we just bring 100% outdoor air in all the time? And although that sounds good, and when the temperature's right, you can do that, the reality is that majority of the operation of your equipment, the maximum outside air you're going to be bringing in is probably 20%, 80% of that being returned. So any benefits from naturally occurring oxidizers in the outdoor air get spent as it mixes with your return air. And it doesn't give you a lot of reoccurring and continuous clean or sanitization, I should say, in the space. If we could open it up and dump a ton of outside air, some of our customers on this call may have energy recovery units that are bringing in 100% outside air, exhausting 100% outside air. In those situations, they're definitely getting benefits that traditional packaged equipment doesn't give you.
Thanks, Brian. So we're back to the question on what steps people can take place in our recommendations for how to improve indoor air quality as well as combat COVID-19. And some low-cost options that we would highly recommend is that you have a regular scheduled preventative maintenance plan. This typically consists of quarterly visits with filter change and periodic system checks. In addition, typically routine system cleanings are done when these preventative maintenance are being performed. Filters, as early as, or as recently as last Thursday, I was listening to Governor DeWine's press conference, and they had a doctor from OSU, and he was telling everybody to, put in HEPA filters or more MERV 13 filters. And it sounds great, but really you should replace filters regularly, but make sure that they're rated appropriately for your mechanical system. And lastly, for a low cost option would be get as much fresh outside air in as possible without being a detriment. And then Brian, do you want to elaborate on any of those low cost recommendations?
Right, so if you have building controls, this could move into the lower cost side, but making sure that you're scheduling the buildings to be off when you're not there, heating to and cooling to reasonable temperatures, and then if on the weekends or if you're off for long periods of time, making sure that your set points don't go too far and having some purge cycles. That helps tremendously. I mean, at the end of the day, there is no silver bullet. There is no one product that we can stick in there, walk away and say, you're 100% covered. It's still a bunch of small things added up to create a healthier environment and an environment where your mechanical equipment lasts longer, which is really a return on investment.
Yeah, and it's you know the CDC and the state of Ohio have put these protective measures out on the streets, right? And we can add to those layers, but like Brian said, there is no magic bullet on this one, and we can only put as many barriers to mitigate the transmission of COVID-19. If it was a simple equation, we probably wouldn't have a pandemic on our hand, unfortunately. That's all the slides we had. We said we would try to keep this to a half-hour presentation. We are at 31 minutes, so I say we open this up to the group, and if we have any specific questions, whether we covered them or not, feel free to ask.
Oh, this is Allison. It looks like we might have dropped Nicole accidentally. She's offline. I'm sure she's trying to reconnect. So in her absence, let me jump into the questions here. Someone asks for your thoughts on bipolarization in commercial. I hope I pronounced that correctly.
Bipolarization? I'm not necessarily familiar with that.
Okay. Well, if they want to type in this is certainly not my field of expertise. So if the person who wrote that question wants to type in clarification, I'd be happy to relay that information. In the meantime, moving along, what can be done with, again, forgive if I'm jumbling this, PTAC units?
PTAC. So
PTAC.
Yeah. Brian, I'll let you describe this, but PTAC is very common. Go ahead, Brian.
Yeah, to my knowledge, there really isn't a PHI or a UV. There might be some smaller residential style UVs for PTACs, but continuous maintenance and filter changes. I know PTAC units specifically, the filters get forgotten about, or worse, they take them out, don't put them in, and it ends up building up with dust, dirt, contaminant, lowering its efficiency, and then ultimately making it die. I think most PTACs die from lack of maintenance, probably more than any other item.
So if anybody doesn't know, a PTAC is a self-contained air conditioning unit you typically see in hotels. Now they have more of a centralized HVAC system, but PHI does exist. They do have application for PTACs. We have not been requested to provide a quotation on that, but I do know that technology and that product does exist.
Okay, thank you. Next up, what kind of budget is required for a PHI installation? I realize that size probably matters, but any estimates?
Great.
I'm pretty comfortable with at least going out from a budgetary standpoint. You're around $2,000 to $2,500 for your typical 3 to 10 ton HVAC package unit, and then as the airflow and tonnage goes up, it goes up from there fairly linearly, at least on the cost of the equipment. The install is pretty much the same. It's a very low voltage, so there's typically no reason to run extra power, run off the equipment, and then interlocked with the fan relay or your control system.
Yeah, and I did some quick math on this. I think it equates to about $75 to $150 per ton. So if you know your tonnage, maybe use that as a calculation. But we're typically looking at about $75 to $150 a ton.
Okay, great. Nicole, I see you're back. I'll take the next question and then pass it back over to you for moderating. Next question is, can UVC and PHI stand alone, and why are you combining them?
Good question.
Yeah, that's a great question. UVC stands alone by itself. Typically, PHI or photohydroionization uses UVC with the metal catalyst to create the oxidizers. So when you do PHI, you get UVC at the same time. So that's kind of how that works.
And the reason I think this is important, and I'll kind of dissect this question a little bit more as well, is that with UVC, the contaminant or the pollutant has to cross the light rays to go in effect. So if you can guarantee that, then UVC is a perfect option. But if you're trying to combat anything that's airborne, and in this case, speaking directly about COVID-19, is droplet based, you need something working out in the air for you, which are those oxidizers, which is what PHI provides. I hope that answers the question.
Yep, I think that was good. Nicole, are you back with us?
Can you hear me now?
Oh, yeah.
Okay, great. Sorry, I don't know. We had some internet technical difficulties here, so I was able to call in from my phone. If we don't have any additional questions, then...
Oh, Nicole, we do have, I'm sorry, you probably can't see them because you're calling in. I'll run through the rest of the questions if that's okay.
Okay, yes, please do. Thank you, Allison.
We have, are there any websites that the presenters recommend for further information? And the person said thank you. Thought you didn't want to know that.
Yes, there is links, data sheets, studies we can provide. We'll probably take that one offline, figure out how we can maybe upload the video with appropriate links so everybody has access to them. Maybe GCP has some recommendations how we can distribute that kind of information.
That would be good.
Yeah, absolutely. We could include it in the follow-up emails. If you guys wouldn't mind sending that info over, we can send that to everyone.
Great.
All right. There has, oh, this is a long one. There's been suggestions about increased humidity in buildings. What are the potential pitfalls if done poorly with this, or advantages if done correctly? How can this be accomplished with constraints of most existing building systems?
I'm assuming this is being asked specifically on some of the information that's come out from the CDC regarding increased humidity actually being harder on the virus and decreased humidity actually helping it grow. And there's always a trade, right? As you add humidity and specifically latent load, you're cooling, you're going to end up having to drop the temperatures to get that humidity up and actually feel comfortable. We've done a lot of research on this, and right now, I personally, and this could change. There's all, this is a very fluid situation. I don't feel that raising humidity in a space above what is typical, right? Like 60% humidity in a 72 to 75 degree space is usually the top end. Raising it above those levels, I don't see a benefit personally, but I think that we're going to have to work through that one a little bit more. Austin,
yeah, I read a piece actually today from ASHRAE, and they were recommending that the kind of sweet spot's 40 to 60% relative humidity indoors is kind of try to maintain, but that's typically what buildings are working to maintain to begin with. They say that, sub 40% that the virus has the opportunity to transfer or travel longer distances. So there's definitely some validity behind that, but like you said, it's a fluid situation, and we're actively keeping on top of it.
Yeah, and I guess to go back on what I said, I don't think going beyond what is already recommended in buildings, like Austin said, 40 the bottom side, 60 the high side. Moving beyond that, I think it starts adding a lot of other problems and unintended consequences.
Okay, great. Next question, how much does a UVC PHI system cost?
I mean, this is similar to the figure I gave you on tonnage. I think, Brian, you could probably just give a kind of a high level budgetary number for everybody, because we knew that was going to come up, which is totally understandable.
Right, and I think we kind of touched on this a little bit a little while ago. So if you're talking about your standard package equipment, which 3 ton to 10 ton, which could be in a whether it's a pizza shop or your standard multi-tenant commercial office building, roughly $2,500 per unit is probably a good number. And then the equipment cost goes up kind of linear from there, and the installation kind of stays flat because the electrical or the electrical usage or current or capacity doesn't change a lot. I mean, it goes up, but it's so small that it doesn't impact your installation, and the way you install it isn't as impactful as just the cost of the equipment itself.
And we're talking about light commercial and commercial buildings with those figures. There are similar residential grade products for the home, or if you own, a small real estate company or a restaurant, and you have, a residential HVAC system, there are solutions for UVC and PHI for those systems as well. So everything suggested in this webinar is scalable from, 1 or 2 people up to hundreds, if not thousands.
Right, and another piece to remember, if you do go buy something that's more residential based, although it might be effective and work, typically it's not made to be maintained or each item replaceable like a commercial system. So long term, it might end up costing you significantly more than putting in a commercial solution that actually has the ability to be maintained throughout its life cycle.
Okay, great. Now I do have clarification on the other question about bipolar ionization. I'm learning a new word every day here.
Yes.
I had 2 people write in with clarification. One said she thinks the previous question was referring to bipolar ionization, charged oxygen molecules that surround and neutralize molds, bacteria, etc. And another person, the original author actually said products like atmosphere global plasma solutions disinfects the air by producing and distributing a controlled amount of positive negative air ions which interact with oppositely charged elements.
This is while we were talking, I looked it up, and I actually brought Adamus Airs up. I'm not as familiar with this. This is a fairly new technology. It's not as tried and true as PHI and UVC. UVC and PHI is very heavily used in the medical and specifically the food industry, the meat packing industry, because of its continuous sanitization capabilities. I don't know enough about this technology to speak to that right at this moment.
All right, it looks like we are all caught up on questions here. Oh, I'm so sorry, one more just came in. Does the age of the HVAC units matter as it pertains to effectiveness?
If they're referencing UV or photohydroionization, no, the age of the equipment doesn't matter. What really matters is sizing the equipment specific to the airflow, which roughly equates to tons. Of course, there's some differences there, but airflow is key in sizing that. So no, the age of equipment has nothing to do with that.
All right, great. If there are no further questions, and it looks like there aren't unless someone wants to slip one in, of course, they can always reach out to GCP or to Air Force One with any further questions. We will be sending a recording of today's webinar with everyone. Thanks so much for Air Force One. Thanks to everyone who attended. Nicole, are you there? Would you like to close us out?
I am. Thank you, Allison. Just as Greg alluded to in his opening remarks, Ohio really is leading the way on so many aspects of this virus. And just as he said, resiliency is definitely a choice in what we do for our people and for the health and well-being of our buildings. And your building's roadmap should incorporate an integrated approach, just like we've talked about today, from those low to no cost measures to incorporating, of course, preventative maintenance to more capital intensive things as budgets become more available. But we know that there isn't a one size fits all. There's not a silver bullet to this uncharted territory with this virus specifically. So you should plan for both selecting solutions that will serve the immediate but also long-term needs. And again, thank you, Allison, for jumping in and assisting today. And most importantly, to thank our today's speakers and all of our attendees for joining us this afternoon. If you do have any specific questions related to any of the energy services, how the Greater Cleveland Partnership can assist your business in re-entry, reopening, any resources related to the economic recovery, please do reach out to us. Our staff is fully prepared to assist in any and all of those challenges. And with that, thank you again all for attending. Be well and stay safe.
Take care.
Thank you.